Hello. Okay, today we're going to start talking about arithmetic sequences and series. Here are our learning targets. All right, what is an arithmetic sequence? And also today we're going to talk about series as well. An arithmetic sequence is pretty simple. It's a sequence where the difference between the terms is the same. So between consecutive terms. That common difference is called lowercase d. And if we look at this first one right here, you'll notice that between each term we are increasing by 4. Just adding 4 every time. That, because you are adding the same number every time, we call that arithmetic sequence. You can also be subtracting the same number each time, but it's just the difference between the terms is always the same. So maybe this one here is going down, and you'll notice between the terms here, we're just subtracting 5 every time. So in this one up top, my common difference is 4, and this one right here, my common difference would be -5. So an arithmetic sequence simply is you're adding and subtracting the same number every time. That makes it arithmetic. Okay. Determine whether the sequence is arithmetic, and then if it is, find the common difference, which is d, and the next term. So let's take a look. What's happening with this right here each time? And is it the same? This looks like to be adding 6. Yep, it looks to be the same each time. So yes, it is arithmetic. And then the common difference is 6. The next term is, well, if we take 14 and add 6, we would get 20. So the next term is 20. All right. How about this one? This is a sequence. And here we are subtracting 3. This one we are subtracting 6, then 9, then 12. Now, because these are not the same, this is not an arithmetic sequence. So this is, no, not an arithmetic. That's how you know if it's arithmetic, just adding or subtracting the same number. Okay, so the general rule or explicit rule for an arithmetic sequence is this right here. A sub n is equal to a sub 1 plus the common difference times n minus 1. So remember a couple of things. This just means first term. Okay, this is your common difference. And then n is your term number. So maybe the 12th term or the 15th term or whatever. Okay, so that is the general rule for an arithmetic sequence. And this is nice because if you are asked to find a really big term, then you can just find the rule and then plug in and go from there. So let's take a look at how that might be useful. So here it says find the 30th term of the arithmetic sequence 20, 14, 8, 2, -4. Now, I could write out all 30 terms and then write down what the 30th one is, but that would take a while. So is there a faster way? And that's the purpose of this. This generalizes the rule, and I can get there a lot faster. So let's try it. Now, we know that we need n. Now this time we do know what n is. They're asking for the 30th term, so n is 30. I also need to know what a sub 1 is. So a sub 1 is the first term. You'll notice that that's 20. And then my common difference, I can figure that out. you can see here it looks like we are subtracting 6 every time. So my common difference is negative 6. Okay, now I have everything I need to write the rule and then find the 30th term. So let's see, a sub 30 is equal to a sub 1, which is 20, plus the common difference is negative 6, so I'm going to put that in parentheses. And then just following this, it says n minus 1. So 30 is my n minus 1. Okay, let's simplify. (30 minus 1 is 29). Now I do need to use PEMDAS when I simplify this. So I can't go 20 minus 6 or plus a negative 6. I have to do this multiplication first. PEMDAS says multiplication comes before adding. So we need to do negative 6 times 29. So I'm going to open up my MCA calculator. Negative 6 times 29 is negative 174. Okay, so and now if I add those two together, I got to add 20, right? So now 20 plus negative 174 will be negative 154. So the 30th term is negative 154. And then I want to look, does that make sense here? Well, if I'm going down by 6 each time, I know even in this next term here, I have negative 4. The next one would be negative 10, then negative 16. So if I go all the way to the 30th term, it's going to be a pretty big negative number. And that's what I have here. So yeah, that makes sense. I think that probably will work. So a sub 30 is negative 154. Okay. So sometimes they'll write it a little bit differently, but this is the same premise. Write a rule for the sequence, then find the indicated term. So again, I want to use this formula that we set up here and write a general rule. Okay, so I want to know the 24th term. So n, let's go to my pen here, I guess. N equals 24. And a sub 1 is 20. And then my common difference, let's take a look. This one here is negative 9. It's going down by 9 each time, right? Okay, so that's negative 9. Okay, so if I want to find a sub 24, I know that I have 20 plus common difference of negative 9 times n minus 1. Now the n that I know is 24, so that would be 24 minus 1. Now I need to figure out what this is going to be here in a second. I'm going to have to do negative 9 times 23 probably on my calculator. So let's do that. I get negative 207. All right. So I know a sub 24 is equal to 20 plus negative 207. If we add those together, that's 187 to the negative side. All right. And there is the 24th term. And again, that looks like it would make some sense here as we're going down by 9 each time. Okay. So hopefully the arithmetic sequences and writing a rule are making sense. Now, sometimes they might give you a couple of terms, but you need to find the missing terms. So notice here we start at at 17 and we end at negative 13. But 17 then would be, this is a sub 1. And this one is a sub what? Let's see. This is 2, 3, 4, 5, 6. So this is a sub 6. So I want to figure out what's going on here. Now, the easiest way, or one of the ways that you could do this, is if I could figure out what my common difference is, then I could figure out each term afterwards. So that's what we're going to do. Now, we're going to just use the formula, but I know that I know the sixth term, so that is my n, is 6. So if I say, hey, a sub 6 equals a sub 1, plus the common difference, which I don't know, but I do know everything else. N is 6. Now I can plug in for here and here. I just plugged in there, so we're good there. Now let's just plug in. A sub 6 is negative 13. A sub 1 is 17. Plus the common difference, right? And then 6 minus 1 is 5. So now I'm just going to simplify that a little bit. That's 5d. And now we can just solve this two-step equation. So subtract 17. I get negative 30 equals 5d. And then I'm going to divide by 5 to solve for d. So d equals negative 6. So now I know my common difference is negative 6, meaning each time I go to the next term, I'm going to subtract 6. So let's say I go 17 minus 6, that's 11. 11 minus 6, 5. Then subtract 6 again, I get negative 1. Negative 7. Now, if I did it right, if I subtract 6 from negative 7, I should get negative 13. I do. So I know that I did this right. But that's how you do a problem like this, is solve for your common difference here. You have all the other information. Now, there are other ways to go about this too, but that's using the formula is one way you can do that. Okay. Sometimes you're given a scenario, a real-world scenario, and this stuff is just organizing really and then putting into what you know already. So it says a high school auditorium has 18 seats in the first row and 26 seats in the fifth row. The number of seats in each row forms an arithmetic sequence. What is the explicit definition for the sequence? And then part B says how many seats are in the 12th row. Okay, so if the first row has 18, we know that's a fancy way of saying, hey, I know a sub 1 in this sequence is 18. I also know that the fifth row has 26 seats. So I can do similarly to what I did in the previous problem. Now, I knew the first term and the sixth term in this one, right? I knew the first and the sixth, those two. And then we set it up to look like this. This time we just know the first and the fifth, so I'm going to do the same kind of thing. So a sub 5 equals a sub 1 plus common difference, and then n minus 1, n is 5 minus 1. Okay, now I can plug in everything I know here and solve for my common difference. Now I do know that a sub 5 is 26. This is 18. The common difference I don't know. Okay, so I have 26 equals 18 plus 4d. Now subtract 18 from both sides. All right, let's go over here. 26 minus 18 is 8. These cancel out, so I have that. Divide by 4, divide by 4. What's my common difference? It's 2. Okay, so this explicit definition that I wrote first helped me solve, and now I have the common difference of 2. Okay. So now I want to know the 12th term. Common difference would be 2, and then, okay. So let's see, a sub 1 we said was 18, right? And then 12 minus 1 is 11. So I have 18 plus 22, which is 40. So in the, I guess we should write this out, 40 seats. That would really be my last answer there. Okay. All right, now arithmetic series. A series very similar to a sequence, except that you add these together. So I take the sum of all the terms of an arithmetic sequence. So take a look at this. This is my sequence, 6, 12, 18, 24. Now in a series, what we do is we take those same terms and we add them together. That makes a series, okay? Now if I want to know what is the sum of the first like 10 terms of a series, I don't need to write out all 10 and then add them together. I can just use this explicit formula here, and it makes it a little faster. So that's what we're going to do. We're going to try it out. Okay. It says find the indicated sum for the arithmetic series, and in this one they want the S sub 8. So what? Or I'm sorry, S sub 18. What that means is they want the sum of the first 18 terms. Now, if you write out all 18, that's going to take you a while, and then you got to add them all together. So this is going to be way, 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 way faster to use. So let's see what we know. Do we know what n is? Yes, we know that that's 18. Okay, do we know the first term? Yes, it's right there. It's 13. Okay, I also need a sub n, and in this case, n is 18, so it's a sub 18. Do I know that term? No, I don't. I know the first 4, but I don't know the 18th term. So in this case, this is a question mark. So in order to start, before I can actually use this formula right here, I need to figure out my 18th term. So that is this one right here. I'm going to have to use that formula that we have already tried. So let's do that and then go from there. So in order to do that, I also need you'll notice that formula needs my common difference. So what's happening with this one, right? This is subtracting 11 each time. So my common difference is negative 11. So that's what I'm going to use here to figure out a sub 18. First term is 13 plus my common difference of negative 11. And we're going to go, my n is 18 minus 1. Okay, now if you multiply that together, let's do it. We get negative 187. Now we also could probably just go ahead and add 13 right now. So we got negative 174. Okay, now we just did those two together. And we get negative 174. So now, I'm going to switch colors here. I know that this is negative 174. So when I do my problem here, I can use this formula right here now. Okay, so S sub 18 is equal to 18 times, let's see, a sub 1 is 13 plus a sub n, which n is 18, so this is going to go there, plus negative 174 all over 2. It's a little tight there. Let's clean that up. So when I do this, I want to do everything in the parentheses first. So I'm going to add 13 plus negative 174, right? So if you're not sure, just go your calculator. 13 plus negative 174 is negative 161. Okay? So that's the top. And then I'm going to divide that by 2. And then I need to multiply by 18. So let's go ahead and do that. Negative 161 divided by 2 is negative 80.5. And then I need to multiply it by 18. We'll do that. Let's write it out first. Okay, times 18. Okay, we get negative 1,449. Okay, so that is the sum of the first 18 terms, would be negative 1,449. Okay, now a little bit of work, but very doable, just using the stuff that we've learned today. Okay, summation notation. This is another way to write a series. And we use this capital letter, Greek letter, right there. That is a capital sigma. And it means in math sum. Okay? So it says this is to denote the sum. That means add them together. So what you'll see is on the top of the sigma will be the last term, right here. In this case, that's 5. The first term number will be at the bottom. Okay, that'll be, in this case, 1. And then they have, it'll say n or x or whatever. In this case, it's x. And then this will be the formula will be written right here. This is the formula to find the sequence. And then the summation, the sigma, means add that sequence together. Okay, so a lot of information, but really, let's say we did this here for this one. It would be find the sum of the series above. So what you would do is just take and plug in 1 through 5, right? Here's 1, here's 5. We're going to plug in the 5 into this here. So if I put a 1 here, I get 2 times 1, which is 2. Okay? So this is how we get the sequence. And then we're going to put in a 2. 2 times 2 is 4. Then a 3. 2 times 3, 6. 2 times 4, 8. And then 2 times 5, and this is where we can stop, right? Now, what we do then is, remember, the sigma means add them together. That's what creates the series. So really what we're saying is 2 plus 4 plus 6 plus 8 plus 10. Okay? All right, so you got 10. This is another 10, that's 20, and then this is another 10. That's one way. Or you just type it all into your calculator. But if you were to add these all together, this actually equals 30. So that's the sum of that series. Okay. So sometimes it's a little bit more tricky. And notice, you got this. So this time, instead of writing out all 11 terms, we're going to try to use this guy. Okay, so what do we know? We know our term number. In this case, it goes 1 through 11. So our term number is 11. There's 11 terms. Okay, I also know I can figure out the first term. I don't know it yet. I also would need a sub 11. So I need to know these two. And all I have to do is plug in 1 here and see what I get. And then the second time, I'm going to plug in 11 and see what I get. Okay, so let's put in 1. 13 times 1 minus 5. That's 13 minus 5. Okay, so a sub 1 is 8. Right, this equals 8. Okay, well, we still do need to figure out what the 11th term is. So now I'm going to go 13 times 11 minus 5. 13 times 11 is 143. Okay, minus 5, which would give me 138. Okay, now I'm going to use the formula here. So S sub 11 is equal to 11 times the quantity. Let's see, on the top we have the first term 8 plus 138 divided by 2. Figure out what we get. Okay. So 8 plus 138 . Okay, so we're going to do 146 divided by 2. 146 divided by 2 should give us 73. And then you might want to type that into your calculator, 11 times 73. We get 803. So this is 803. Okay, and that is everything on arithmetic sequences and series that we'll cover in this class. Hope that makes sense. Bye.